about those various jobs and about some of the advice I would give so you can avoid making mistakes that I made along the way. So, I am working as a disaster researcher. I actually, technically speaking, have a master in disaster, where I work with fluid dynamics and catastrophes. So I once upon a time worked on the beginning and end of the universe, and I moved from there to the far more practical black holes. But then I went, you know what, really, black holes, not going to be a problem in the solar system, so I worked on volcanoes on Mars. And then I realized I wasn't quite actually suicidal enough to be a volcanologist. You do need a bit of a death wish to work in that field. It's really exciting, but it is the shortest life expectancy of any scientist. So I moved on to working on landslides. And it turns out all of these things are fluid dynamics, just simpler and simpler and simpler fluids. So I've done that, and then turns out that a lot of my classmates have also been working in research. So right now, if you work in physics as a researcher, you're either going to be working on a very, very large project. I have classmates who are working at CERN, that's a large hadron collider in Switzerland, and they have teams of hundreds of people who all work adding little tiny pieces to a giant puzzle. And the neat bit is, if you add those little tiny pieces, sooner or later, hopefully, they're going to discover entirely new physics. So that is awesome, except that you are working on little tiny pieces with giants of hundreds of people, and it's very hard to feel ownership of the project. You just have parts of it. But you get really cool equipment. You get equipment that takes seriously many countries to fund, and looks really awesome. So you can do big physics, or you can work in lab environments, and those can be industrial labs, or they can be research labs, or they can be all sorts of labs. And in lab environments, generally speaking, your equipment budget is much smaller, although national labs have good equipment budgets. And you spend your time, you need to be able to do things and repeat them, and repeat them, and repeat them, and repeat them. You know this about science. It doesn't work unless you can do it several times over. So you have to be somebody who is willing to do, you got it, you figured it out, now do it again. Now do it again, 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 now break something and do it again. And the classic thing about labs is something will always be broken. So if you work in a lab, you will actually be fixing your machines quite frequently. And you will occasionally make big discoveries by completely goofing up. So I was out to dinner with a friend the other night. She's telling me she builds these graphene, the coolest new material there is. You need carbon and you evaporate things on. And they went through and they did their test and their results looked fantastic, and then they realized they forgot to add carbon in at all. So their best results were from a complete, total goof, where it turned out you just needed so little carbon it was stripping the remains that were left inside the vacuum chamber. So you've got to be willing to have things go completely not at all how you planned, and you've got to be willing to do it over and over and over again, and you need to be willing to create your own processes, that somebody isn't going to tell you do A, then B, then C, or they will tell you that, and then you'll figure out you don't need to do B at all. It's actually A and C work fine. So that's what lab environments are like, and I highly, highly recommend, as if you go to university, almost immediately try and get involved with the lab. And the way you do that is you see something that looks interesting. You look on the department web pages, you go to a class and say, that is the coolest professor. You go, you know what, I always really liked elephant seals. And you walk up to the professor and say, I'm interested, I'm curious, and I promise I will show up every day. That last bit is really important, is the I promise I will show up. And most teachers get really excited when someone's enthusiastic. I teach a 300 to 500 person lecture on disasters, and I, on average, meet 4 of my students per term. So I have 4,000 students a year, in-person distance ed. Those 4 students who come up to me and say, I actually think disasters are pretty cool, could you help me out? I'm going, yes, please, let's talk about any disaster and I will help you out as much as I can. So professors get excited when you come to office hours. We're bored. We're really bored, we have to be there. You might as well come entertain us with your questions, and we'd love to have you in our labs. So don't be shy about that. The next job that I do is I work in the entertainment industry. So I work for film companies who realize that audiences get a little annoyed when the guns have infinite ammunition, or if they have a slightly smarter audience, get annoyed when everything falls into a black hole when it was a sun a minute ago. So they want plausible science in there. So every time you have that genius scientist scrolling on the board thinking things through, there's an actual real scientist whose handwriting that is. So the show of mine that you most likely have seen would be Stargate Atlantis and Stargate Universe. Those were all the handwriting for all of the scientists. There's variations on my handwriting. I actually got in trouble on my first day for my handwriting being too neat, because scientists aren't legible. We don't care if that's a 2 or a 5, apparently. So I got to teach them about science along the way. I am working on other shows since that one's been canceled, but they're currently under non-disclosure agreements because they haven't aired. So I'll come back in a few years and talk about them. What you need to do to work in the entertainment industry is be really flexible. So it's easy to point out how fictional science is wrong. It's easy to go, well, nothing can travel as fast as the speed of light. You can't have teleporters. No warp drive for you. But that makes for a really boring story. So instead you have to find a way to make things plausible. You have to be creative with it. You have to say, well, all right, so what you really want is an electromagnetic storm that happens every 22 minutes. Well, you can have a pulsar, but pulsars go really, really fast, like several times a second fast. And if you had a pulsar going that slowly, the actual electromagnetic field would be about equivalent to holding fridge magnets and doing cartwheels. So that's not going to be particularly dangerous. So how do I make this work? I know. I can have a pulsar and I can have a feeder star, so like some big gas thing that only comes by in its orbit every 22 minutes. So during that time it's coming past, it's flashing a whole bunch. But hey, for humans, we don't care. We don't notice this happen multiple times a second. But there I've got my little big baddie to come around every 22 minutes. And I'm obeying plausible astrophysics. Is this likely to happen? Have we ever observed it in the solar system? No, we've never observed it anywhere in the entire universe. But it could happen. And that's what you do in the entertainment industry. You can do it in any field. I do astrophysics, geophysics, physics, but you could do it with biology as well. Stargate also had a full-time medical consultant whose job it was to do things like make sure the x-rays were the right way up. So if you decide you want to get involved in that sort of work, what you do is you go to school, you become a scientist, and then you volunteer. The National Science Foundation has a Science and Entertainment Exchange. And you volunteer with them and say, I'm a scientist, and I'd love to talk to people about science. And they'll hook you up with gigs and say, well, here we have a movie that wants to produce something about pathogens, and they need to find out how epidemics spread. And you go and you chat with them. And to start with your volunteering, you're doing it for free. But if you communicate with them and you're creative with them and you're enthusiastic and positive and a nice human being, they go, yeah, I'd love to keep working with you. So I'm going to hire you on as my consultant. So that's how you do that type of work. What is it actually like? Well, you spend a whole lot of time waiting. So you get hired and the day is a 12-hour day and they actually only need you for 2 scenes. So most of the day you're just sitting there, but you're sitting there and they're willing to pay you to just sit there and wait and stay out of the way and be quiet, because at some point the director's going to yell, astrophysics! And you run over there and you answer whatever question he has, and then you wait. Then you wait some more. And then they're filming your scene and they're writing things and you have to erase them and reset the equations and teach the actor how to write a lambda because they don't know Greek. And then you wait. And wait some more. And then you crowd into a little tiny room so that one of those photos there is a little tiny office that's like less than the space behind this desk, and there were 12 of us in there during filming and it had to look like an empty room. So it was a little bit squish. So that is what it's like to actually work in the entertainment industry, and the fun bit is you do get to meet people like Neil deGrasse Tyson and Bill Nye the Science Guy and go, well, I actually produce your science. And they go, it's so nice to meet you. Let's talk about Martian chondrites. So it's very fun that way.
Bill Nye.
Yes, I've met Bill Nye the Science Guy and Neil deGrasse Tyson. They were both on Stargate. It was very fun. The next chunk is what I do as my primary job, how I spend most of my time, is I'm a field geophysicist. And a field geophysicist is kind of like being a mix of MacGyver and a James Bond villain, in that you go around and you fly by helicopter and you land somewhere and you provoke the planet into telling you its secrets. So what do I mean by that? You start with stringing wire out everywhere. All geophysics jobs pretty much mean wire. But you get to string out wire in interesting places. Those are both in Madagascar. And then you put a bunch of sensors along it. If you're doing an electrical survey, you stick metal spikes in the ground because they're like lightning rods. They'll collect all your electricity for you. If you're doing seismic work, you will take a little geophone, which I will talk about a bit later if I've got the time, and you'll collect vibrations from that. And then you do something to provoke the planet. So you pound 2,400 volts into the ground and see what it does. Or you blow things up and see what it does. The work environments for this are all over the place. I've had jobs where I've worked out of the back of an SUV just stringing things down a borehole the whole time and been warm and cozy, and it had a sound system. It was fantastic. I've also had ones that required a full day hike to get up to the top of an